Okay, I'm going to begin the trig part of the review stuff here in Chapter 1. Chapter 1 has some trig stuff mixed into it, but then Appendix D in the book, which is at the back, is a trigonometry section that would be really worth your time to look at and make sure that you're fine with the problems there also. Now, just like with the algebra stuff, we're going to highlight certain things here. I mean, the field of trigonometry is a big field, okay, and so I'm going to just really kind of give you the information that I think you'd want to know going into a calc class, and then, as the trig stuff comes up, if we need to cover anything else, we'll do it on an as-needed basis. So, of course, everybody's had trig before prior to this class, and so everybody should be familiar with the basics of trig. You need to know how to work with the basic angles, the common triangles, and then graphing, okay? So, just like with the algebra, like this is intended to be a review here. A lot of what we do with trig revolves around the unit circle and or working with triangles. And so if I have a point on a circle of radius r, suppose that point is xy, okay? I've gone x units to the right or to the left, and then y units above or below to plot this point. And I would build this right triangle inside this circle here, and here's my angle theta, here's my right angle, and I can define the trig functions then. Sine of theta is opposite over hypotenuse, okay, or y over r. Cosine of theta is adjacent over hypotenuse, x over r. Tangent of theta is opposite over adjacent, okay, or y over x, okay. The other three functions are the reciprocals of these three, okay. So cosecant theta would be the reciprocal of sine theta, that is r over y. Secant theta would be the reciprocal of cosine theta, that would be r over x. And then cotangent theta would be the reciprocal of tangent theta, which is x over y, okay. Let's take a look at problem 13. The point 3, -4 is on the terminal side of an angle theta in the standard position. And standard position just means that one of the sides of the angle is on the x-axis here. And we want to find the exact value of the 6 trigonometric functions of theta. All right, so I plotted this point 3, -4 on this circle. And the radius of the circle would be 5. Now, one way to get that number would be to use the Pythagorean theorem. Okay, if I go 3 units to the right, 4 units below, and plot that point, I've created a right angle here. And of course, you can use the Pythagorean theorem when you have a right triangle. The sum of the squares of the legs equals the square of the hypotenuse. Okay, so for this problem, 3 squared plus -4 squared would be the same as 5 squared. Okay, you get 25 either way that you look at it there. So 5 would be the hypotenuse of that triangle. And of course, this is one of my common triangles. This is a 3, 4, 5 right triangle, probably the most common Pythagorean triple that you would ever work with, and so let's compute the values of the 6 trigonometric functions of theta. Now, sine of theta is opposite over hypotenuse, so for us that's going to be -4/5. Cosine of theta is adjacent over hypotenuse, that's going to be 3/5. Tangent theta would be opposite over adjacent. So the opposite side is -4, adjacent side is 3, -4 thirds. Cosecant theta would be the reciprocal of sine theta. Sine theta is -4/5, so cosecant theta would be -5/4. Secant theta would be the reciprocal of cosine theta. Cosine theta is 3/5, so secant theta would be 5/3. Cotangent theta would be the reciprocal of tan theta. Tan theta is -4/3, so cotangent theta would be -3/4. Okay, now just an observation here. When you compute values of trig functions and you draw your triangles, make sure that you pay attention to whether one of the sides is going to be a negative. Okay, I see more than I should where a student draws a triangle and misses the sign. Okay, now they gave us a point here. Okay, but in other examples, if you're working with one of the common angles, you may forget to put a negative on a side when when in fact it should be a negative. So problem 14, part C, here would be an example of what I was just talking about, and I'll get to that in shortly here. But in problem 14, we want to find the exact value of the 6 trigonometric functions for the given angle. We're going to do this without a calculator. One reason why we're not using a calculator is because we want the values to be exact values. Okay, I'll comment on that again here shortly. But all right, part A, I've got an angle measure of pi over 6 radians. That's the same as 30 degrees. Okay, and of course, one complete revolution around the circle would be 360 degrees. 30-degree angle would put me into quadrant 1. And a fact about triangles is, all 3 of the angles in any triangle add up to be 180 degrees. So if I've got a 30-degree angle here, here's a 90-degree angle here, and the remaining angle would be 60 degrees then. Okay, this is one of the common triangles that you would see in a trig class. There's 2 common triangles that you see all over the place in trig. A 30, 60, 90 right triangle, and then a 45, 45, 90 right triangle. Of course, talking about the angles there. So opposite the 30 degrees is 1. Opposite the 60 degrees is a root 3, and opposite the 90 degrees is 2. Now that I've got my triangle set up, I can compute the values of these 6 trig functions. Sine of pi over 6, opposite over hypotenuse, that'd be 1/2. Cosine pi over 6, adjacent over hypotenuse, that'd be root 3 over 2. Tan pi over 6, opposite over adjacent, 1 over root 3. Okay, and if you were to rationalize the denominator, that'd be root 3 over 3. Don't rationalize the denominator unless you're told to do that. Okay, sometimes it's fine to rationalize the denominator, and sometimes we don't need to do that. Cosecant of pi over 6 would be the reciprocal of pi over 6 of sine pi over 6. Sine pi over 6 is 1/2. So cosecant pi over 6 would be 2 over 1, or 2. Okay, secant pi over 6 would be the reciprocal of cosine pi over 6. Cosine of an angle is adjacent over hypotenuse, so secant of an angle would be hypotenuse over adjacent. And for us, that's going to be 2 over root 3. Cotangent of pi over 6 would be the reciprocal of tangent pi over 6. Tangent of an angle is opposite over adjacent, so cotangent of an angle would be adjacent over opposite. Root 3 over 1 is root 3. Okay, let's take a look at part B here. So what if the angle is pi over 4 radians? Well, that's the same as a 45-degree angle, and I marked that out here. Of course, I'm in quadrant 1. Here's 45 degrees. Here's 90 degrees, and then the third angle would also be 45 degrees. And yeah, this is another one of our common triangles that we would see all over the place in trig, right? A 45, 45, 90 right triangle. Opposite the 45s are 1s. Opposite the 90 is root 2. And of course, how I'm getting these numbers is through the Pythagorean theorem, right? 1 squared plus 1 squared would be root 2 squared. Over here, root 3 squared plus 1 squared, that's the same as 2 squared, okay? Now that I've got my triangle built, I can compute the values of these 6 trig functions. Sine pi over 4, okay, opposite over hypotenuse, that'd be 1 over root 2. Cosine pi over 4 is adjacent over hypotenuse, that's 1 over root 2. And again, you can leave those unrationalized there in the denominator is fine. Tangent of pi over 4, opposite over adjacent, 1 over 1 is 1. Cosecant pi over 4 would be the reciprocal of sine pi over 4, so that'd be root 2 over 1 is root 2. Secant of pi over 4 would be the reciprocal of cosine pi over 4, so it'd be root 2 over 1 is root 2. Cotangent of pi over 4 is the reciprocal of tan pi over 4. 1 over 1 would still give you 1. Okay. Now here's a note just before we get to the next problem. Always give the exact values when working with the trig functions and using basic angles. I hope that your trig instructor, whoever that person was, emphasized that when you took trig. Okay. a lot of what we do with trig doesn't involve calculator activity, okay? Especially when it comes to working with basic angles. And the reason why I would say, I hope your instructor emphasized that is because in calculus, we do lots and lots of trig. Okay, I sometimes tell my calc students, hey, you're going to become trig machines in this class, in the calc sequence. Okay, and the reason is because we do lots and lots of trig. It's just the nature of the course. Okay, nearly every day in a semester, you're going to be doing something with trig related. So obviously, it's important to know the basics when it comes to trig and not have to run to a calculator for basic things that that you're going to be building on. For example, don't write cosine pi over 4 is 0.707, okay? That would actually be a wrong answer, since if you were to type in cosine of pi divided by 4, it's not 0.707 and then it just stops, okay? It's an infinite decimal. So obviously we don't want to use an equal sign there, right? This is not an exact answer. That's a wrong answer, actually, okay, since it's roughly 0.707 if you go nearest 3 digits. You will not get full credit since 0.707 is not the exact value. There'd also be a notational problem if you're using an equal sign when it should be an approximation sign. So, be sure that you're aware of that. I'd be looking for 1 over root 2, not 0.707, okay? And unless you're told otherwise in the problem, always give the answers in exact form for me, okay? That's how the book will want it also, right? Let's take a look at part C. We have a 120-degree angle. In radian mode, that would be 2 pi over 3 radians. And by the way, a lot of the problems that we'll be doing that are trig related are going to be where we are in radian mode, okay? So consider that for the material here. And of course, how to convert an angle that is in degree measure to radian measure, you're just going to simply multiply by pi over 180 degrees and then reduce. All right, so if I take 120 degrees times pi over 180 degrees, 120 over 180 would be 2/3, right? And so 2/3 pi would be my angle, but now in radian measure. If I wanted to convert an angle that is in radian measure to degree measure, I would multiply that by 180 over pi. So like pi over 4 times 180 over pi, the pi's cancel. 180 divided by 4 would be 45 if you reduce that. Okay, so here'd be a 45-degree angle that we'd be working with. All right, so 120-degree angle is going to put me into quadrant 2. Now, I am building a 30, 60, 90 right triangle, but it's in quadrant 2. Okay, because here's 180 degrees if I make half of a revolution around the circle there. So inside the triangle, this angle is 60 degrees. Here's a 90-degree angle, and the angle up here, the third angle, would be 30 degrees. Opposite the 30 degrees is 1, but since I'm going to the left of the center, I want that to be a -1. Okay, now here's the mistake that I will see students make that I brought up earlier. I'll see students accidentally just leave this as a 1, and where it should be a -1. Okay, make sure that you're paying attention to the signs. Like I see this more than I should, which is why I mention it. Okay, so opposite the 30 degrees in this triangle would be a -1. Opposite the 60 is root 3, and opposite the 90 is 2. Okay, I've got my triangle set up, and I can compute these values here. Sine of 2 pi over 3, opposite over hypotenuse, that'd be root 3 over 2. Cosine 2 pi over 3, adjacent over hypotenuse, that'd be -1/2. Tan 2 pi over 3, okay, opposite over adjacent, that's root 3 over -1 is -root 3. Cosecant pi over 3 would be hypotenuse over opposite. That'd be 2 over root 3. Secant of 2 pi over 3, that'd be hypotenuse over adjacent. 2 over -1 is -2. And then cotangent of 2 pi over 3, that would be adjacent over opposite. -1 over root 3 is -1/2. negative 1 over root 3 that I got written. Okay. Part D. Now, I brought up on the other page there basic angles. Okay, what I mean by basic angles are like there's angles that are going to come up all over the place, you know, like 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, okay? Multiples of 30 degrees and 45 degrees are common angles, okay? And so we sometimes label them as, you know, basic angles. Now, along with that, I could also use the terminology major angles and minor angles. Okay, the major angles would be 0 degrees, 90 degrees, 180 degrees, and 270 degrees. Okay, those would be the 4 major axes here in my picture. The minor angles would be all the other angles that are not the major ones, okay, that are common angles, you could say. So like 30 degrees, 45 degrees, 60 degrees, okay, 120 degrees, like those are the minor angles, okay? Still common though to us. So here I've got a major angle, okay, 270 degrees, and whenever you're working with the major angles in trig, it's convenient to work with the unit circle, okay? So I've got a circle of radius 1, and I've got points labeled, and I can compute my values of these trig functions here. Okay, now sine of an angle is opposite over hypotenuse, but I don't have any triangle built here, right, with this being a major angle, so I wouldn't want to look at it as opposite over hypotenuse. But instead, I would want to look at it as y over r. Okay, so with a 270 degree angle, I'm going to be working with this point, 0, negative 1. The radius of the circle is 1. So y over r, well, negative 1 over 1 is negative 1. Okay, cosine of an angle is x over r. The x-coordinate is 0. 0 divided by 1 is 0. Okay, tangent of an angle is y over x. There'd be a problem with that, right, because x is 0. I know I can't divide by 0. So I'm going to have something that's undefined. Okay, now, of course, be careful about this. I will see students sometimes write, like in this problem here, they might write negative 1 over 0 is undefined. Don't do that. The reason why we're saying that it's undefined is because we can't divide by 0. Like, we don't want to write that down. Division by 0 is not allowed. Okay, so it should be just something that we observe. Hey, there's a problem in the denominator. We don't want to write that down. That'd be bad. Okay, but because we can't divide by 0, we're going to have something that's undefined then. Okay. Cosecant of an angle would be the reciprocal of sine of that angle, so it's going to be r over y. 1 over negative 1 is negative 1. Okay. Secant of an angle would be the reciprocal of cosine of that angle. Cosine of an angle is x over r, so secant of an angle is going to be r over x. X is 0 there, right? So there'll be a problem with division by 0. That's not allowed. So I'm just going to write undefined. Cotangent of 3 pi over 2 would be the reciprocal of tangent of 3 pi over 2. There was an issue with division by 0 here, but when you flip the numerator and denominator, you're going to have 0 divided by negative 1 is 0. So cotangent of 3 pi over 2 would be 0. Okay, we'll stop the video there.